Percent error is really, really similar to percent change, except instead of dealing with the change and the original, you're dealing with kind of like the difference between which is same thing as change, the subtraction amount, the difference between what you think the amount's going to be and what it actually is, and then your prediction or your guess, and then you're multiplying it by 100. If that doesn't make that much sense yet, let's take a look at an example. Say that your club had a fundraiser. You predicted that you would raise $50 from this fundraiser. So that's your prediction right there. That is your guess. Okay, but what you actually raise is $45. So the way to find the percent error is to figure out what's the difference between those two numbers. Well, this one's a pretty easy example, so we probably don't need this step, but we'll do it just in case. If I'm not sure what the difference is, I subtract. So I realize that there's a $5 difference between those two numbers. Then what we're going to do is we're going to take that 5 and we're going to divide by our prediction or our guess. So I'm going to do 5 divided by 50. Okay, and get your calculator out. You're going to get a decimal. You end up with 0.1. And then you multiply it by 100 to change it into a percent. So 0.1 times 100 gives us a 10%. That's a 10% error. So my guess was 10% off from what it actually is. Okay, let's do a couple of the examples from the packet. We'll do the first two together. Mrs. Rowan allotted 30 minutes at the beginning of class for her students to complete an exam. The last student took 42 minutes to complete the exam. What is Mrs. Rowan's percent error? Well, just like we did on the last one, we want to think about what is the difference between what she guessed, that was 30, that was her guess for how long it would take, and how long it actually took. So it actually took them 42 minutes. So I'm going to do 42 minus 30 to figure out the difference between those two numbers. And there's a 12-minute difference between those two numbers. So then we take our 12 and we are going to divide by the guess or what we thought it would be. So 12 divided by 30 should get a decimal. End up with 0.4. And then I take that number and I multiply it by 100. So it turns out Mrs. Rowan had a 40% error. Look at the next one. Harper needs to mail an envelope. She weighs it at home as 10.4 ounces. When she gets to the post office, the clerk weighs it at 9.6 ounces. What is the percent error in the weight of the envelope? Well, again, her guess when she's at home is 10.4 ounces. At the post office, they weigh it as 9.6 ounces. So just like the last one, I want to start by figuring out what is the difference between those two numbers. Don't forget to line up your decimals here. 10.4 minus 9.6 is going to give us, 0.8. So we have a 0.8 ounce difference. And then we're going to divide by the guess or the original amount that we thought it was going to be. So we're going to divide by 10.4. I'm going to write this to 3 decimal places because it's going to help me round. So 0.7, maybe they write a few more out. I'm sorry, 0.0. Erase that. 0.0769. I'm writing it to 4 decimal places. I think they round in this answer key to two decimals after the percent. So then when I multiply that by 100, I'm going to end up with 7.69%, okay? Let's round to 1 decimal place after the percent. So I want to round to this decimal place. I look at the 9, okay? 5 to 9 tells me I go up, so this is about a 7.7% error. Okay, hopefully that helps you get the rest of the answers on this page.